this video, we're going to be going over the VRBP100 gas system and some of the reasons why you might experience some ammo sensitivity and some of the reasons for it and how you can go ahead and correct it. So first thing I'm going to do is I'm going to go ahead and disassemble the front part to expose the gas system. Now that we have disassembled this to the point where we can see the gas system and basically the action and how this thing works, you can see here that you have a few things going on here. You can see that this basically silver or stainless rod right here, this is where what I'm going to call the operational rod, where that holds on to the bolt, and this is basically like the carrier for it. And you have the piston, which is basically right at the front here. As you can see, this little piece right here is the piston. So this thing is pushed back by this piston, and you can see this spring right here gives it forward pressure. And when you first get this shotgun, it is under a good amount of pressure, and then this piston right here is the 2 3/4 inch piston, and it also comes with a heavy piston for 3-inch Magnum shells. So this one is going to be the one that's inserted for the 2 3/4 inch. This one is going to be quite sensitive, and that's because a lot of the people getting this are in America, and America is notorious for watering down their loads. So basically, we have a problem with this being sensitive with ammunition that is going under 1,300 to 1,400 feet per second on as far as velocities are concerned on practice ammunition. For the most part, defensive ammunition does not have a problem because it is technically full powered, and as long as it's not a low recoil variety, as long as it's getting full force, this piston will not have a problem giving a generous amount of energy rearward to force this thing to cycle properly. So let's go ahead and break this down, and I'll go ahead and show you the individual pieces of this and talk about it a little bit more. So you can see here that I've gone and just partially pulled out everything. The barrel is out and the bolt and carrier and everything is still technically together, and then you have this gas piston here, which I will go ahead and maneuver the camera to zoom in on it. So you can see this piston has an O-ring on it right here. This holds it into a detent in here inside the I guess you could say the gas chamber. So basically where this piston locks in with this O-ring to keep a nice tight seal. So this piston needs to build up enough energy. A lot of times the 2 3/4 inch shells have just enough powder to push the load out, and almost some of them are actually subsonic, so that's why they're really cheap, is they're subsonic loads just for practice, skeet shooting, you know, whatever, trap shooting, doesn't matter. But basically, it doesn't have enough pressure building up in this gas system right here to force this piston back, because the gas system is only getting a portion of the gas. And most of the time, you're going to find that most of the loads are not going to be able to cycle this. This is made in Turkey. Turkish ammunition is what is generally available in Europe. Europe does not have the watered down specifications that we have here called SAMI spec. SAMI spec ammunition is typically watered down compared to European standards, or basically the rest of the world. So their pressures are generally higher. We typically try to, in SAMI spec, they typically are trying to, here in America, keep the pressures, you know, below what the normal, I guess you could say, threshold is, to where, you know, you see with pistol ammunition you get plus P. Well, usually plus P is basically the standard that you'd find with European ammunition. Depending, like NATO ammo, that's normal European ammunition. So they have to label it as plus P in order to be able to sell it or be part of SAMI specification and approved. So with that said, this piston is going to need a little bit more force in order to push it back. And then not only that, the operating rod has this recoil, has this spring right here that is riding along, and it's got to be pushing this this rod all the way back to where this bolt is going all the way into the back of the weapon fully, to where it can basically take the downward spring tension off the magazine, give it time to kick up another shell, and then when it's on its way back, it can actually scoop up that shell and throw it into the chamber. So that is basically how this system works. And it's no small chore for an engineer to come up with something like this for a shotgun, because shotguns have so many different there are so many different types of loads for shotguns out there, and you have to be diligent. You have to understand the weapon you're working with. A lot of the semi-automatic tubular shotguns, the ones that have tubular magazines, they're typically going to be a little bit more reliable in my mind, because they typically have a little bit more of a direct gas system than this does, and there's just, it's a little bit less complex, I guess you could say. Being a magazine-fed shotgun, it requires a little bit more pressure from the gas in order to function properly, and that's the thing. That's why the VRBP100 is mostly reported to be reliable with heavy practice loads or defensive loads. This is not really something that was meant for, you know, a cute day at the range. They basically took a system that was meant for hunting, and if you know anything about hunting loads, they're pretty high powered, because your target needs to be hit with a good enough amount of energy, and it has to have a good enough range in order to have an effect on the target. So this was made, it's basically taking a functional hunting shotgun system and putting it in a bullpup chassis. That's the good thing about this. However, you know, you got to understand that throwing your practice loads in this, there is a gamble. However, now we're going to get to the point where you can kind of get around this, and you can kind of slack a little bit on this. And that is basically working with this. And the way you work with it is just not clean it as diligently. So the inside of this gas chamber here, just wipe it out. Don't put any lubricant on it. Wipe this off and don't put any lubricant on it. So the risks and hazards here is this thing can wear out a lot faster. However, the gas, the powder, the fouling, I guess you could say, the residue, the firing residue from the gas getting shoved in here, it'll cake up, it'll make this chamber a little tighter, it'll require less gas, there will be a little less room for the expanded gases to go, and it'll build up pressure faster, causing it to need less pressure to start moving forward, and it'll be able to direct more of that gas, that little amount of gas, to basically cycling the operation rod, causing cycling of the shotgun. So, with all that said, that's as simple as it really is. I'm not saying don't clean your clean this shotgun. I'm just saying that there's a way to still clean it, but not be basically making it to where this thing is not you know, working properly. So with wear of this spring right here, I guess you could call it a recoil spring, and with wear on this spring, and also with this piston, you know, getting less of a detailed cleaning and lubrication, you can lightly lubricate around this area, but if you're going to be doing that, I wouldn't wipe this off so much, and definitely not wipe off this area too much. You can do a light lubrication, but try not to lubricate inside here or clean this out with your CLP or cleaner if you want to get it to be more reliable with these lower powered you know, target loads. So with all that said, that's pretty much my little spiel on the VRBP100 gas system. If you like this video, go ahead and share it around with friends that might be interested in this, or go and share it if you wish. I appreciate it, and thanks a lot for watching. You guys have a good one.